Hi everyone. My work uh, just for your information, it's not completely or like directly mechanistic interpretability, but rather like as a support tool for researchers doing mechanistic interpretability. My work is about creating an AI alignment knowledge graph. So AI alignment, right? It's the process of encoding human values and goals into large language models to make them as useful, safe, and reliable as possible, according to IBM. And we all know that AI alignment nowadays is a burgeoning field of research with, I believe, no universally or like very structured paradigms yet, and new researchers who and uh, especially you guys who would want to get into AI alignment would probably appreciate a way to help you navigate this like growing field quickly and as comprehensively as you can. So that's the purpose of my work. So what is a knowledge graph, right? So a knowledge graph is a graph that contains entities and the relationships between them. By applying this concept towards a field of research, creating a knowledge graph for a field of research could help us identify credible and trustworthy research papers and articles, provide context around a piece of work or an idea that you want to look into. And also, it helps us spot emerging trends and within the different fields of research. And probably also could help us track like the careers of like budding scientists uh and all that. My work takes inspiration from some recent AI alignment hackathon winners. This one is an AI alignment knowledge graph, which used an LLM to read through articles and sort of automatically categorize them. One thing I found with this is that it's pretty simple categorization with only like three layers. Here it is. Each of these nodes is like one article, but if you can see, it's quite a simple graph where like they only connect like it's only each node is only connected once. I believe that there could be lots of room for improvement with regards to this work. Another research work, also fairly recent, that I am taking inspiration from is ArdMap from Stampy AI. So in this one, they compiled around 13,000 documents from archive, research journals, and also blog posts regarding AI safety, AI alignment, and all that. And they try to visualize it. I hope you guys can see clearly, but um, uh, it might not be clear here, but uh, I guess that's one thing I'm trying to improve. Trying to improve how this graph looks like and how you can see the different categories. Zooming into that, for now I don't quite see a good uh grouping of articles that makes sense. Yeah, that's what I'm trying to improve on. So the data set that I'm using is the Stampy AI alignment research data set, which contains documents from Alignment Forum, Archive, various blogs like Less Wrong, and a lot more. But at least for my work, I'll be limiting it to what I consider are like more structured, more quality papers. So I took some from Archive and Alignment Forum, and those are the only ones. This is also to exclude like the bias, the sort of doom posting that might be common in blogs. For my work, it's uh, hopefully like purely academic or scientific. So for my methodology, what I did was I got those articles, I got their titles and their full text, and encoded that into one data point. So once I have that text, I run it through a token an LLM tokenizer. The one I use is Allen AI Spectre 2. which is a recently developed LLM tokenizer specifically for research articles. So what this does is it takes the text. Oh, sorry. Yeah, it takes the text from the data set and transforms each encoding of the document into a high dimensional vector. So like you can imagine like 2D, 3D, imagine 768D. So that's the kind of information that I'm working with. And not that's not really helpful for us humans to visualize, right? So on top of the tokenizing, I reduced the dimensions using dimensionality reduction. The algorithm I used was UMAP, or Uniform Manifold Approximation. So this condenses those 768 dimensions to 2 dimensions, which we can easily graph and visualize. This is an example of the graph I was able to come up with. And the graph alone just gives us a scatter plot. But aside from the scatter plot, I did clustering, which is an unsupervised method. I used k-means and HDB scan, which I will explain later on. Uh, After clustering or like coloring it based on the groups, I visualized it and analyzed it manually. So I had to skim through a lot of abstracts and articles just to get a sense of what these colors, what these groups mean. Hopefully, I'll be able to automate that process later on using an LLM. But yeah, and what I want to come up with, like the final step of my work, would be a search method. So enabling researchers to be able to search this weird data space that I made. So that's still a work in progress. So I won't be able to present some results for that for today. But okay, so going back. So I used k-means and HDB scan. So from the documents, I was able to create a 768 dimension token vector for each document and do this for like 4,500 documents, reducing each document to a point in 2D space. Um, the first clustering I used was k-means, and these are methods to help us identify how many clusters is like the best for both methods that I used, which is the silhouette score and the elbow method. They all gave me a value of 5. So, okay, I told my k-means algorithm to cluster the data into 5 groups. And here, these are the clusters that I was able to come up with. But what does this actually mean? That's that's where the hard human reading part comes in. So I went through a bunch of abstracts and titles and articles and came up with uh well, what I would consider like strong, cohesive topics or themes within these documents. We have mostly the neural network side on the upper left, AI alignment fundamentals in the middle. We have reinforcement learning, which is actually surprisingly a big part on the upper right. And on the lower right, we have a literature review and future predictions like, oh, what's AGI gonna be in the next 5 years? When are the Terminators coming? Uh, that kind of stuff. Oh, yeah. So k-means relies on the idea of you have to tell k-means how many clusters you want, which isn't really helpful. It's like, okay, we want to know this research, but we need to know how many categories in this research field there are, which isn't really doable, I believe. So I also tried another type of clustering called density-based clustering, where I cluster the points based on how dense they are. And I used the HDB scan, which is one of the more performant density-based clustering methods. And I was able to come up with this. I call this conservative HDB scan because here each point considers around 70 other points to to decide which neighborhood it belongs to. So Apparently, I was only able to cluster find two clusters and some noise. And when I looked at them, I wasn't able to cluster this big one because it's very widespread. But the one on the upper right is still reinforcement learning. So yeah. Um, Interestingly, though, with HDB scan, instead of having a conservative minimum number of samples to test on, we can also set it to a really low minimum number of samples. So what it does is that instead of each point looking at 70 other neighbors to decide what color it is, we can tell each point to just look at one neighbor. And I believe there's some potential there because uh like if we compare it to like the other graphs, these nodes, these documents, they only consider like one neighbor too. So I believe that by lowering the minimum number of samples, it kind of makes it conceptually similar to making a graph like this. Yeah, so I called that the instead of the conservative, I called that the liberal HDB scan. Wait, no, I know other words. I know other words, but like, yeah, what it gave me was these interesting clusters, smaller clusters within the bigger cluster. Uh, the only drawback of this is that it's more sensitive to noise. So as you can see, there's a color there. Sorry, I'm colorblind, but I think that's green. And it's -1. That means it's noise, and we're not sure what cluster they belong to. So ignore the green ones and focus on the ones that have color. So looking through these, I found a very promising and I would say cohesive uh, categories within them. Like interestingly, the one that had AI fundamentals in the K-means, they split into policy making, AI safety countermeasures, and benchmarks or evaluations. The neural network side from the K-means split into neural networks, like the basic neural networks, and then also LLMs. And there's a specific chunk here for interpretability, like mechanistic interpretability, which is what this organization is about. So being able, maybe in the future, we could hone in on this section here to come up with a better knowledge graph specific to mechanistic interpretability. And aside from that, there are also like mathematical theories, probability theory, game theory, even agents and behaviors. This section here, I would say, is more on the humanities side with human values and robots, the risks of AGI, the roadmap of technology development, and over there on the top right, it's still reinforcement learning, and also another reinforcement learning, but I would these methods have more unsupervised effects on them. So yeah, that's a that I would say that was the most reinforced category from all the results I had. So obviously this work isn't the final work. There's still some changes that I want to do. Firstly, have an LLM help me categorize all the information. And I believe that passing the full text into the tokenizer might be a crude method for now, but it works, but it could be quite crude. We can probably use an LLM to help synthesize or summarize the data first before passing it into the tokenizer. Um, Another thing I tried to do was include a citation, the information of citation. So papers that cited each other, I would force them to be closer on the graph. However, I wasn't able to finish the code for this one in time. Uh, and finally, um, uh, going back to what I said about interpretability, I wanted to kind of hone in on a specific field. So specifically mechanistic interpretability. And I believe that one way that we could improve uh, a, a, a project like this is to get rid of the topics. So like, for example, from Smavli's talk, it was about disambiguation, but like the methods he used are still used in other problems as well. It's just that he applied it specifically to disambiguation. So I believe that if we can make it topic agnostic, we can actually look into the specific algorithms, methodologies, and processes, and we can probably make a better graph out of this. And yeah, I think that's it. That's my progress for now. Thank you for listening.
Yeah, so the floor is now open for questions. So maybe we should start with the people here. Alex.
Uh, yeah. I wonder if you investigated like the common keywords, or I guess in this case it would be the frequencies of tokens per cluster. I mean, I think that um, the categorical labels seems to be um, like just a label, but obviously there's more sub labeling and sub networks that are available there. And for example, I can see that the neural network portion probably contains words like activation and loss, and meanwhile the humanities words could have stuff like scaling or uh, effects, right? So have you investigated that?
Yeah, for the current work, I wasn't able to integrate that concept into the program, but I do believe that that's one improvement that I can do. So probably it has to be, I believe, like also human made to determine to have like a database of words for that field that people usually associate with that field. I wasn't able to do that since this is a really big field, but I think that if I focus on one of these smaller categories, I could be able to make like a list or like a database of like what are the common terms to expect, and those probably will be the entities or the sort of the dots in the future instead of the whole document is one dot. Probably it'll be more along the lines of having one concept is one dot. But yeah, thank you for bringing that up.
Yeah, cool. So yeah, so our next question. Oh, I mean it's a bit, but yeah. Anyway, yeah. So our next question comes from Zoom, right? So here. So yeah, yeah. So are you planning to convert your data into a network graph, like add edge for distance if distance is within threshold? So if so, I wonder if computing net centrality scores can help profile the clusters. So the nodes with the highest scores might represent the core topic of their clusters.
Oh yeah, that's a good point to bring up. I believe that at least with the clustering libraries that we have, I might be able to uh, do something like that already, uh, where we can get the like the sort of cluster score. Um, but yeah, that's an interesting thing. I also know that there's like this concept of graph neural networks and also graph RAG, which is like the new thing to help LLMs. And I'm wondering if this could be like this work could be a start to making that graph RAG specifically for AI alignment. I don't know. It's that's just what I'm wondering. But yeah, thank you for bringing that up. I'll consider it.
Yeah, so anyone else in the audience who has questions? So this is very interesting work. Yeah. So yeah, I'm not sure if there's anyone who's like done this to the degree that he has or he plans to do. So Ah, all right.
Can you go back to the slide with the plot of the k-means clustering? Oh, the next slide, I think. Oh wait, oh yeah. What do you think is what's the fifth cluster? Yeah, the blue one.
Yeah, I couldn't really see like a very strong theme in this cluster. Um, but if I can reference um the later uh visualizations, I believe it's more along the lines of having mathematical models, probabilistic models, or like it was stuff like modeling utility or uh very conceptual or theoretical framework stuff, I believe. So I think that's what it is, but yeah, not sure.
All right, cool. So yeah, any other question from the audience? No? People on Zoom. Mm. All right. So yeah, that's it for JI's presentation. So again, thank you very much, JI, for the very interesting idea. Yeah. So